Hi everyone, welcome to this video. In this video, I want to take you through my latest project. So this is the story of how I built a real-time server monitoring system with AI forecasting, or in more particular, you can say it with the help of time series forecasting. So why did I make this project? How did I come up with this idea? Let's talk about that, and then I'll jump to the code, and then I'll discuss what I did there. So I was actually exploring a very neglected side of ML. It is time series forecasting. So while I was exploring time series forecasting, I got this idea that our servers get traffic, and this traffic can be logged properly in a time series fashion, and then with the help of this traffic, we can predict how much traffic our server is gonna get in the future, right? So this was my approach. What I did was I took the data from my own local PC and I extracted that and logged it in a database. Many of you might have heard about it. It is InfluxDB. And then with the help of that, I trained my time series model. And for the real time thing here, which is monitoring, I use Prometheus and Grafana. So this is pretty much it. Let's just explore the code base and how the project looks. Okay guys, so let's begin. I wanted to show you the design first, what I have implemented. We have a Docker Compose YAML file that we run to run all the services which are mentioned here, which are Node Exporter, InfluxDB and Telegraph, Prometheus, Grafana, Streamlit and MLflow. So we also have live and batch. So in live monitoring, we have used these three services which are mentioned, which is Node Exporter, Node Extractor, Prometheus and Grafana. So what does Node Extractor do? It takes all your metrics of your server which are running locally currently. So it takes that and exposes a HTTP endpoint, which then Prometheus uses to pull the data of the server. So what I have used is CPU and memory usage. So you can use other metrics as well if you want. And then we also have Grafana. So Grafana, what it does is it takes data from Prometheus and builds a beautiful dashboard which is live. And apart from that, we have batch training. So we have implemented InfluxDB, which is a long-term data storage solution, and then we pull data hourly from a service called Telegraph, and then we can run model training hourly. And I wanted to also emphasize that this model training that we are doing hourly can be done like in 4 hours, 8 hours, 12 hours, or maybe 1 day, 7 day, even 1 month, whatever you want, right? And then we have implemented MLflow. So MLflow is able to log all these model training, and it is also able to provide us all the artifacts and everything else. So yeah, let me show you each component. This is the InfluxDB, which is everything is currently running locally. So this is the InfluxDB. I know it is not much, but yeah, this is what it is. And this is the dashboard. Yeah, this looks cool. So this is how everything is. So this is the CPU cores, this is the RAM usage, whatever, right? And this is the Prometheus, which is, again, it is a database, but I implemented Influx. I didn't use Prometheus because this is a pull based database. So you can use it for training, but I preferred InfluxDB for long term storage. Apart from this, we have MLflow, and here you can see all the models that I trained while I was making this project. So yeah, and this is the Streamlit app. So this is forecasting for the next 4 hours. Okay, and this is the CPU analysis, this is the memory analysis, right? So everything looks like this. And I also have a blog which I wrote, which you can go through if you are interested. I'll drop a link to that as well. So what does this blog cover? This just covers how I made this project, right, in more detail. So yeah, let's start with the project and how it looks. So this is the complete structure of the project. one thing which I would recommend you also is to make your code, or rather code base, modular, so that it can be easily scaled and debugged as well. So let's talk about the source folder first. In this we have a pipeline structure which I followed for model training. So what it does is, this is the ingestion.py file. This takes data from the InfluxDB, makes a CSV of that, which goes into the data raw folder. This is the system matrix CSV. So what it has CPU usage and the memory usage, right? We have that. So this is what ingestion.py is doing basically, right? Apart from that, after ingesting, what we do is we try to pre-process, right, our data. So this is the code for that. It handles nulls and makes sense of our complete data, whatever we have. And this pre-processed data, which is now cleaned, goes into pre-processed folder, which is this. So this is how the pre-processing step works. After that, we have model training, and this is the complete logic for that. We are training a Sarima model, as I said earlier, I think. So yeah, we train the model with this, and this is the inference one. So what does inference mean? It just means that you are trying to forecast what will happen or predict with the help of your trained model. So this is what this script does. And to top it all off, I made a main.py. So what this does is, you just run this script and it will run each of these components one by one, all of these modules one by one, right, which you can see. So you don't need to run each of the module one by one. You can just run main.py and everything will be taken care of. So this is how it works. So this is the main source folder. This is typically being used for training our model, right? And apart from that, we have the app.py. This is our Streamlit app, which I just showed you. And this would be used for us to see what our model is forecasting in the future. And this another thing that I implemented is, I implemented a Docker file for the Streamlit app. So with the help of this, we can make a Docker image and then run that image in a container. And we have a docker compose.yaml file. So the interesting thing about this project is, you can run this project with the help of, I think, 2 or 3 steps. You don't need to set up a lot of things. Most of the things are taken care of with the help of Docker Compose. So you have services like Node Exporter, Prometheus, Grafana, all of this, and these are just running with the help of one command, which I think is Docker Compose up, right? So you will be able to see that. And I wanted to show you how the matrix look. I think it is running on 9000, I guess, or 9100. Let me check it real quick. Okay, not this one. I think it's 9100. Yeah. So this is what Node Exporter is, or Node Extractor is sharing over the HTTP endpoint, right? So this is how it looks. Yeah. Apart from that, what I wanted to show you is, this is the dashboard YAML file. Yeah, so this is the complete dashboard file, which actually I got this from the Grafana official website. I didn't write, of course, all of this code. I got it from the how much it is. It is around 23,000 lines. So this is the JSON actually, so I use that, and this is the data source. So what does Grafana use? It uses Prometheus as the source. Yeah, so it does that, and these ML runs, all of this are for the ML flow part, right? And I have also implemented .env. So this don't worry, this is not this is not very unsecure. This is running locally, so I can show you this. Generally it is not recommended to show .env files because they have sensitive information, but this doesn't contain any, so I am showing you that. So this has passwords and all, which and tokens, whatever I just showed you, right? So if you try to log in this, let me see if I can show you that. No, actually it is already logged in, so I'm not able to do that. But when you log in, it will ask for admin name and password, or the user ID and password, and you have to put whatever you have hard coded it. And yeah, and I also made a setup.py file, so you can use this file to set this up locally, and it will be easy for you to go through the entire process of setting up. And yeah, that's pretty much it. Yeah, thank you so much for watching.